Math 2, Unit 4.4, Medians and Altitudes. Okay, so our third line segment we're going to talk about in relationship to triangles is a median. A median is a line segment that joins the vertex of a triangle to the midpoint of the opposite side. So we're just going to sketch this, but if we found the midpoint of, say, this side of a triangle, and we'll say this is the midpoint, and we connected that midpoint with the opposite vertex, this would be our median. This is our median right here. And of course, every triangle has three medians, so if we found the midpoint of this side of the triangle, and since we're just sketching it, we'll say it's right there, and from the midpoint of that side of the triangle to the opposite vertex, that would be our second median. And of course, if we found the midpoint of the third side and we connected it with the vertex of the opposite side, put those two lines there, those congruency lines there, well, this would have 3 since it's a scalene triangle. We would have drawn all 3 of our medians. And again, the median goes from the midpoint of one side of the triangle to the opposite vertex. Okay? Just like our other two line segments we've talked about, the medians will all meet at a point of concurrency of the triangle. That point of concurrency is called the centroid. Okay? And the point of concurrency or intersection of the medians of the triangle is called the centroid. And the centroid has something special about it, just like we talked about the perpendicular bisectors, circumcenter, and we talked about the angle bisectors, incenter. The centroid has something that's special about it. And what we know about a centroid is there's a relationship to the two halves of each median at the centroid. It's a 1-to-2 relationship. So if this was, let's say, 1 centimeter, this would be 2 centimeters. And if this was, say, 4 centimeters, this would be 8 centimeters. And if, let's say, this length here was 3 centimeters, then this length up here would be 6 centimeters. It's a 2-to-1 relationship. The shorter side of the median is from the side of the triangle to the centroid, and the longer part being from the centroid to the opposite vertex. So a 2-to-1 relationship. 1 to 2 if we go in this fashion here. Okay? So using the information, let's go ahead and work through some of these problems in our notes. All right, if P is the centroid of triangle JKL and JK is 22, so if we know that JK is 22, well, since P is the centroid, we know M must be the midpoint of JK, so we can say this is 11 and this is 11. KN is 13, so from K to N it's 13, which means N to L must be 13 since we know that N is the midpoint of KL. And OL is 18, which means JO is 18. So now we'll go ahead and fill in our blanks over here. KM is 11. NL is 26. KL is, oh, I'm sorry, no, my mistake. NL is 13 and KL is 26. JO is 18 and JL is 36. Okay, moving on. If V is the centroid of triangle PQR and SR is 21, all right, so SR is a median, and remember we said there's a relationship of a 1-to-2 relationship. So that means if SR is 21, SV must be 7 and VR must be 14. a 1 to 2 relationship. And if VU is 8, VQ or QV must be 16. And if PT is 15, PV must be 10 and PT must be 5. All right, filling in our blanks. SV is 7, VR is 14, QV is 16, QU must be 24, PV is 10, and VT is 5. Moving on. All right. So I think we sufficiently covered this, so we're just going to go ahead and skip this part here. And we're going to move on to finding the centroids of a given triangle. All right, so this first one is not too bad. Remember, the centroid is the point of concurrency of all three of the medians. And you'll remember a median is from the vertex to the opposite midpoint. So these two midpoints will be pretty easy to find. We'll just count 1, 2, 3, 4, 5, 6, 7, 8, which means the midpoint must be at 4. So 1, 2, 3, 4. And we'll draw our median to the opposite vertex. Okay. And this one we will count 1, 2, 3, 4, 5, 6, 7, 8. So that means at 1, 2, 3, 4 is our median, our midpoint here. And drawing our median to the opposite one, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, now we need to find the midpoint of this side. Now we probably should use the midpoint formula. That would be pretty easy. We're going to do that over here, but in this one we can actually just count 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So there's a slope of 1, which means if we counted up 1, 2, 3, 4 and over 1, 2, 3, 4, we'd find that midpoint. But what you might realize is we really didn't need to find that midpoint, because if we get 2 of the medians intersecting, the third one is kind of right there for us. Okay, let's go on and find the centroid of this triangle. This one's not going to be as easy because we don't have a vertical or horizontal line to count. So it looks like we're going to have to use the midpoint formula here a couple of times. So this is at 1, 1, 2, 3, 4, 5, 6, 7, 8. So this point right here, we're going to call this A. That's at 1, 8. And B is at 1, 2, 3, 1, 2. Call this B at 3, 2. And C is at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So we'll say C is at 9, 4. Okay, so let's find the midpoint of AB. Midpoint of AB, you remember the midpoint formula is x1 plus x2 divided by 2, or 1 plus 3 divided by 2, and the y values would be 8 plus 2 divided by 2. So we get the midpoint of AB is 4 divided by 2, or 2, 10 divided by 2, 5. So the midpoint should be at 2, 1, 2, 3, 4, 5, and that looks pretty good right there. We'll mark that, and we'll go ahead and draw our median from the opposite vertex to the midpoint of AB. All right, let's go ahead and find the midpoint of AC. So the midpoint of AC will be 1 plus 9 divided by 2, and 8 plus 4 divided by 2. And we get 10 divided by 2, or 5, and 12 divided by 2, which is 6. So the midpoint of AC is at 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Look at that right there. And we'll mark that and draw our median to the opposite vertex. And there we are. Okay. And the nice thing is, we don't need to really find the third midpoint. I can guess where it's going to be, probably about here. But if we draw from the vertex A through the two intersecting medians, we should automatically get the third. And that's where I thought it would be, right there. Okay? All right. I think we can skip this one and move on. Okay, so after we found some medians, now we're moving on to altitudes.